All right, welcome to day 6, and we're going to get started here in chapter 5, section 5.1. In 5.1, what we are going to focus on are the inner workings of a triangle. I know we just kind of came out of a different section for chapter 12, which was circles. Remember, we are going back to chapter 5, and this time we're going to work with triangles. So the first thing that we're going to talk about here are mid-segments. Okay? So mid-segments are segments that connect midpoints of two sides of the triangle. So segments connecting the midpoints of two sides of the triangle. Obviously leaving the third side sort of out of the story. But that third side will play a role in the first theorem that we come to. Theorem 5.1, the triangle mid-segment theorem. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side, and it is half as long. So pause it, let that sink in, absorb that, and then we're going to talk about down here visually. So if D is the midpoint of AC and E is the midpoint of CB, so here's our mid segment. So it's cutting this side in half. And since it's the midpoint of both sides, now understand if it was not the midpoint of the other side, obviously they would not be parallel. But since it's the midpoint of both sides, these are indeed parallel. So DE is parallel to AB. Also, DE equals 1/2 of AB. So putting that straight to use, what are the three pairs of parallel segments in triangle DEF? So pay attention to all the congruency markings. So we have RS is parallel to DF. So RS is parallel to DF. RT is parallel to EF. And then ST is parallel to ED. And let's not forget about that 1/2 property that goes along with that theorem. So it's not asking us that here, it's talking about parallel, but RS would be half of DF, RT would be half of EF, ST would be half of ED. So go ahead and pause it, try the next one. Now this one doesn't give you the picture. So if triangle XYZ A is the midpoint of XY. B is the midpoint of YZ. C is the midpoint of ZX. What are the three pairs of parallels? So that's going to be AC and YZ. AB and XZ. And then CB and XY. Go ahead and pause it, take a look at that, take a look at those colors, match them up. In triangle QRS, T, U, and B are midpoints, so it's really setting up the hypothesis of theorem 5.1. What is the length of TU? So TU is the mid segment compared to RS. So we would say that TU equals 1/2 of RS. Or you can say that RS equals twice TS. You can think of it either way, depending on what's given. Obviously, we're going to want to use the top one. You don't have to set it up like this. You can kind of just do it with your own structure. So we know that TU is going to be 1/2 of 40, which is 20. UB is going to be 1/2 of QS. And TB, which is going to be a little bit different here for TB. TB is already given. So TB is already 1/2 of QR. So we can write it as QR equals twice TB. All right, same idea. Go ahead and pause it. Try it on your own. This time they give you a little bit more information in the givens written rather than in the diagram. So make sure you transfer that over. AD is 6. That means that DC is 6. DE is 7.5. What is the length of DC, AC, and EF? Well, we already know DC. So we got that. AC is just 6 plus 6, which is 12. EF is going to be half of AC. Which is 6. And then the last one they're asking for is AB. AB is going to be related to the 7.5. So AB equals twice DE. So AB equals 2 times 7.5, which is 15. So anything time we do something with geometry and we're measuring, it can always be used in the real world for indirect measurements. What this is saying here is a geologist wants to determine the distance AB across the sinkhole. Choosing a point E outside of the sinkhole, she finds the distance AE and BE. She locates the midpoints C and D. What is the distance across the sinkhole? Now, just measuring across the sinkhole is not something that we can measure. It might be too dangerous. Maybe this is before drones were available. What is the distance across the sinkhole? Well, we can measure here, CD. And since D and C are at midpoints, that makes segment CD a mid-segment. So that means that DC equals 1/2 of AB. And it's kind of hard to see there, but that does say 46. So 46 equals 1/2 of AB. Could have set it up the other way when said AB is twice that. Algebraically, we would multiply both sides by 2. So 92 is AB. So the distance across the sinkhole is 92 feet. And same idea for the next one. Pause it, go ahead and try it. I'm going to write the answer now, so make sure you pause. $13.20, which is half of 2640. So CD is half of the 2,640. All right, that's section 5.1. Make sure you guys attempt the homework problems that are listed at the bottom. Make sure you take the exit ticket. Make sure you watch the next video for 5.2. And make sure you're contacting me with